Good evening, students. I hope you all are doing fine, all good. So today we are going to start with a new topic, which is indefinite integration. I hope you all know indefinite integration. You must have studied it, the chapter indefinite integration. So here, what are we gonna do? We will first start with the meaning of integration, right? So let's start. Welcome, all of you. I hope you are excited to study this. Okay. So as you can see that integration is basically the process of antiderivative, or we can say the process of reverse process of integration is derivative. So reverse process of derivative is integration. Reverse process of derivative. So suppose I have a function f of x, and by taking the derivative, I get small f of x. Then there is a process by which, that is antiderivative. By taking antiderivative of this function, we will get the original function, which is capital F of x. And that process is called antiderivative, or as we know it as integration. So what we'll do now, we will try to find the function whose derivative is known. Suppose let's say x squared, or let's say x. So derivative of x is 1. So if someone asks me what is antiderivative or integration of 1, so we have to think ulta, that what function I will differentiate that will give me 1. What function I will differentiate that will give me 1. So if I differentiate x, I will get 1. So that means if I integrate 1, I will get x. So this is a thought process. Let's try one more time. Suppose sine x. If I differentiate sine x, I will get cos x. So if I integrate cos x, so I need to think what function derivative will give me cos x. Which function's derivative will give me cos x? So that will be sin x, because if I take derivative of sin x, I will get cos x. Simple. So basically this means that all your antiderivative formulae or derivative formulae, if I read it ulta, then it becomes my integration ka formula. It's so simple. If I read the formula of derivative ulta, then I will get integration ka formula. So let's say, now let's talk about next symbol. You all know what is a symbol. You have been studying this from the physics like subject. Differentiation symbol is d by dx. We all know. So what is integration ka symbol? Integration ka symbol is just like the snake. I like to call it snake, just like this. So that means if derivative of f of x is small f of x, then integration of f of x will be capital F of x. So that means, as I gave you an example, derivative of sin x is cos x. So integration of cos x will be equal to sin x. Now, if you know, we have a constant of integration, which we call it as c. So we always have to write plus c because it is a constant of integration. I hope it is clear. After going through the symbol, it's very simple. Let's now talk about the formula. As you can see, if you go through this formula, these are basically the formula which we got from derivative. Like if we read the derivative formula from right to left, I will get these formula. You all know this formula, so please take a look at it, how it can be used. Integration of x raised to n plus 1 upon n plus 1. Constants in the integration is kx plus c. E raised to x, because e raised to x does not have any effect due to integration and derivative. These are new, the 11th one, the 12th one, 9th and 10th. No need to do this now. We will do this after we study integration by substitution. All these formulas, apart from these 9, 10, 11, 12, are basically from derivative. Got it? Please go through it. I hope you all know this formula. This is the algebraic one. A raised to x का a raised to x upon log a. E raised to x का e raised to x sin x का minus cos x. Got it? Let's take some 30 seconds and fatafat will revise this formula. You should go through this formula. Right? Okay. Let us go through this formula. Clear है? Fine. Chalo, let's move forward. Now, what we'll do forward? We'll now study the properties of integration. In derivatives, we had rules of derivatives. So basically, you can call rules of integration or properties of integration. In derivatives, we had 4: addition, subtraction, multiplication, and division. And fifth one was simple constant one. So in integration, we don't have multiplication and division one. We only have 3: constant, addition, and subtraction. And they are same as derivatives. They are same as derivatives. They are same as derivatives. Got it? That means if there is a constant, I can remove the constant outside. If we have integration of two functions, f of x and g of x, and that means integration can be splitted between both the functions. So integration of f of x plus minus integration of g of x. This is the constant rule. This is the addition and subtraction rule. The same as derivative. We don't have multiplication and division rule in integration. We'll see why is that. So let's say this is an example. Integration of 2 cos x plus x square. So I can write this as integration of, by addition and subtraction rule, I can write integration of 2 cos x dx plus integration of x square dx. So that means I can remove 2 by constant rule. So 2 integration of cos x dx plus integration of x square dx. So what is the integration of cos x? So we have to think what function's derivative is cos x. So we know derivative of sin x is cos x. So integration of cos x will be sin x. So I will get 2 sin x plus x square ka integration will be x cube upon 3 plus c, because c is the constant of integration. Got it? Let's study further. Now, do you remember chain rule in derivative? So there is no such thing as chain rule in integration. But yeah, we do have a special property instead of chain rule. So what is that special case? That is, suppose integration of f of x is capital F of x plus c. So if in place of x, if in place of x, yeah, there was my dust in my eyes, it's fine now. If in place of x, we have ax plus b. That is, if in place of x, we have linear term. Which term? Linear term. Then the integration will be same, capital F of x. But we just have to divide by the coefficient of x. What is this? This is coefficient of x. So basically we have to just divide by coefficient of x. So let's say suppose integration of cos x. We know integration of cos x Now previous sum में ही देखा हम लोग ने, it was sin x plus c. So what if x की जगह पे 2x plus 5 है? So that means it will be sin 2x plus 5. We just have to divide by coefficient of x, which is 2 plus c. Got it? So that means sin 2x plus 5, the whole upon 2 is equals plus c is my answer. Let us try one more time. Suppose say example, I get log x. Sorry. Integration of 1 upon x. We know the integration of 1 upon x is log x. So that means if I write integration of 1 upon linear, suppose say 2x minus 5. So the formula will remain same. Log of 2x minus 5. We just have to divide by coefficient of x, which is 2 plus c. I hope it is clear now. This is a very special case and very simple case. It is only possible if we have linear. It is only possible if we have linear. Not possible if we have quadratic or other. So please note this. Got it? Yeah. So let's proceed. Now, next I would like to talk about questions. Let's see few questions. The rules are simple. Here, for example, we have square root. So what do we do in place of square root? We rationalize. It is same from limits. So if I try to rationalize 1 upon under root minus under root, that means I need to multiply by under root plus under root upon under root plus under root. This is my rationalization process. So in denominator we'll get a minus b into a plus b. So a minus b into a plus b will be a square minus b square. So here root will be gone. So I will get 3x plus 1 minus 3x minus 5. And in numerator 1 into this, that means I will get under root of 3x plus 1 plus under root of 3x minus 5. Now in denominator, we can easily see plus 3x minus 3x will get cancelled. So in denominator, we will be getting 1 minus minus 5 plus 5. So that is 6. And in numerator, we will have under root of 3x plus 1 plus under root of 3x minus 5 dx. And from rules first, what is the first rule? We can remove the constant outside. So that means it will be 1 upon 6 integration of, now square root ko I can write raised to half. That is, I am trying to say I can write 3x plus 1 raised to half plus 3x minus 5 raised to half. Now, according to rule number 2, the plus sign integration will get split. That means I will get 1 upon 6 integration of raised to half plus integration of raised to half. Obviously, there will be dx. Got it? So, what is x raised to n ka integration? X raised to n plus 1 upon n plus 1. That means I will get 1 upon 6 bracket 3x plus 1 raised to half plus 1. What is half plus 1? It is 3 by 2 upon 3 by 2. Now don't forget, it is linear 3x plus 1. So that means I have to multiply by coefficient of x. And similarly, here I will get 3x minus 5 raised to 3 by 2 upon 3 by 2 into 3 plus 3. So here, as you can see, something will get cancelled. We can take 2 common out and it will be cancelled with 3. And here 3 threes are 9. So we can take 9 common and it will be multiplied by 3. So it will get 1 upon 27 bracket. What will I get here? I will get 3x plus 1 raised to 3 by 2 plus 3x minus 5 raised to 3 by 2 plus c. This is my final answer. This is my final answer. I hope it is clear now. So it was a good sum for first question. Now let's proceed to second question. Yeah. So what will I do? Here I will give you one hint. That hint is many a times this will work. Huh? Many times it will work. That is split the numerator if denominator has single term. I hope you understand what is meant by term. Here, denominator has sine square x into cos square x, which is a single term. I hope you know what is a single term. That means we can split the numerator. What I'm trying to say is I can write sine cube x upon sine square cos square minus cos cube x upon sine square cos square dx. I hope it is clear. So after this, we can use the second rule. What does second rule say? That in subtraction, integration will get split. Here, sine square will get cancelled and here cos square will get cancelled. So I will get integration of sine x upon cos square x minus integration of cos x upon sine square x. Correct? So, what will I get now? See, here manipulation is important because it is trigonometry. So, here I can write sine upon cos square as sine upon cos into 1 upon cos. Similarly, I can write here cos upon sine into 1 upon sine. Right? You will see why I did this manipulation. So that means I will get this is integration of 1 upon cos is sec and sine upon cos is tan minus here 1 upon sine is cosec and cos upon sine is cot. And we know both of these formulae. Why? Because derivative of sec x is sec x tan x. So integration of sec x tan x will be sec x. So this will be sec x minus derivative of cosec x is minus cosec x cot x. So if I take integration of cosec x cot x, it will be minus cot x. So minus of minus cosec x plus c. That means my final answer is sec x plus cosec x plus c. I hope it is clear now. This is my final answer. Now, if we move on to next, I hope this is a good questions. You have done this. So if we move on to next, let's say suppose the first and the foremost and the most important method. Like after this, all the methods we'll be studying for integration. That will be basically background में क्या हो रहा होगा? Substitution types. Very, very, very important method. So what we can do that, as you can see from this example, this function as a whole was not integrable. What do I mean by integrable function? Integrable function means this function as a whole could not be directly integrated. We need to modify or simplify this function to make it integrable. So such functions, when such cases arise, many times we use substitution. What does substitution do? Substitution basically helps us to simplify the function into integrable form. So once the function is converted into integrable form, we can easily integrate the function. So for that we use substitution. Now, let's say I would like to note that mainly use substitution when we have composite functions. We'll see in examples. You all know what are composite functions. So there are basically these steps which I follow personally. They are from the whole function, uh, find f of x and f dash of x. Like there will be one function and there will be another which is derivative of this function. Then substitute f of x equal to t. Then differentiate this with respect to x. So I will get dt by dx equal to f dash of x. And then if I cross multiply, I will get dt is equals to f dash of x dx. See, when we substitute something, we are changing the variable. Basically here, it was function of x. Now we substituted t. That means now after substitution, my function or my integrable question, my question will be converted in terms of t. That means I cannot integrate. I cannot integrate with respect to x. So I need to convert dx into dt. I need to convert dx into dt. That's why we do the third step. That is differentiate. And that's why we use this substitution. We put f dash of x dx as dt. It will be clear if we take an example. Okay, let's take this example. You please note that whenever there is composite function, we will use substitution 100%. That is basically my motto. Whenever there is a composite function, 100% we will use substitution. As you can see, the original function should have been cot x. It should have been cot x. But here, instead of x, what do I have? I have log x. So that means it is a composite function. So what is step 1? Step 1, put cot x is equals to t. Next was differentiate it. To differentiate with respect to x. So what is derivative of? Oh, it is log x, sorry. Log x. So what is derivative of log x? It is 1 upon x. And what is derivative of t? It is dt over dx. Then what we do? We get dt. So it will be dx upon x. So now I can write my question as, please see how I am writing my question. Integration of cot log x into dx over x. So basically, in place of dx over x, I can write dt. And in place of log x, I can write t, simple. So if I do this, my integral will be converted into integration of cot t into dt. Cot t into dt. Now you might not know the formula because we had cancelled this from this. We had cancelled this cot ka formula, right? But integration of cot is log sine. Integration of cot is log sine. So I will get log sine t plus c. Now, if we obviously it is a rule of maths, we substituted, therefore we also need to resubstitute after getting the answer. So I will get log of sine of log x plus c. This is my final answer. It's as simple as this. Got it? Please note, don't rush through this. Exactly, please use or understand this very carefully. Then we'll move forward. Got it? If it is all good, then we'll move forward. So next, right. Let's use this. There are two examples. Let's say suppose this. E raised to minus x, so I can write 1 upon 1 plus 1 upon e raised to x. Now, if I take LCM, so I will get e raised to x upon e raised to x plus 1 dx. As you can see, this function is not integrable and also it is not composite. So it is not always necessary that we use substitution only for composite functions. No, no, no. We can use substitution anywhere. But if the function is composite, we definitely need to use substitution. So it is like composite implies substitution, but substitution does not necessarily implies composite. I hope you got it. So here to make this function integrable, let's see what we can do. If you remember step 1 and step 2, we need to find f of x and f dash of x. Suppose if this is f of x, then if I find f dash of x, this will be f dash of x. I hope you are understanding. So this is f of x, this is f dash of x. You can clearly see. So what we do, we put f of x as t. So that means e raised to x plus 1 is equals to t. If I differentiate with respect to x, I will get e raised to x is equals to dt by dx. And if I cross multiply, I will get into dx. So if I substitute these both in my question will become very simple. What will it look like? It will be integration of e raised to x dx will become dt. So in numerator will have 1 upon e raised to x plus 1 is t. Very simple. What is integration of 1 upon t? It is log mod t plus c. Now obviously we need to resubstitute. So we'll write it as log of t की जगह पे e raised to x plus 1 plus c. Got it? Now for this question, I would like you all to try this. I will give you all head start. Till then, I'll drink some water. I'm very thirsty. So I'll give you a head start here. You can solve this for 1 minute, then I'll start. It is very simple. You can directly see the hint. Okay, I'm back. Did you try any? Any of you all tried? Okay, so here it is a case of composite function, right? It must have been sec square x, but instead of x, we have x raised to 10. That means we need to substitute x raised to 10 is equals to t. Now, if I differentiate with respect to x, I will get 10 x raised to 9 is equals to dt by dx. That means if I cross multiply, I will get x raised to 9 dx is equals to dt upon 10. Now, if I use this both substitution here, that is in place of x raised to 9 dx, I can write dt by 10. So I will get integration of dt by 10, right? And I will get sec square t. Now, according to the first rule, 1 by 10 is constant. So I will get integration of sec square t into dt. So what is integration of sec square t? Do you remember? It is tan t plus c. Now we have to resubstitute the value of t. So that means I will get 1 upon 10 into 10. T is x raised to 10 plus c. This is my answer. Got it? So it is not always necessary that we have to substitute. We have to only use substitution for composite functions. Many a times we'll be using substitution for just simplifying the question to make it integrable. Let's look at one more. Yeah. Again, you can directly very easily see here the denominator. It should have been sine x, but in place of x, we have x plus log x. Got it? That means I need to substitute x plus log x equals to t. Then I will differentiate with respect to x. So 1 plus 1 upon x will be equal to dt over dx. Right? Here if I take LCM, I will get 1 plus x upon x and cross multiply dx will be equal to dt. So by using these two, we can easily get substitution. So 1 plus x upon x dx. We can substitute it as dt. So what will I get? My integration will be integration of dt. Now what will be happening to 1? It will be as it is, and upon sine t. Now what is 1 upon sine t? It is cosec t dt. Now we also didn't know the formula of cosec t. Here I told you to not remember this one. There are two, but we'll use the first one. So integration of cosec is log of cosec minus cot. So that means here integration of cosec will be log of cosec minus cot plus c. Now we are forgetting something. We need to resubstitute. So in place of t, I need to write x plus log x. That means log of cosec x plus log x minus cot x plus log x plus c. This is my answer. The answer looks very bad. Good answer, like mostly we be happy if we get a good answer, 1, 2, sin x, cos x and all. But the answer is looking very bad. It's fine. But it is my answer. Got it? Okay. Now, after doing these questions, I hope you now ready for some standard integrals. These integrals, we saw the first formula. What is not this one? These all. The first 4 we cancelled. We'll be looking at this now. Now I will tell you how to derive the first one. Rest you can do similarly. Got it? So that is the first one. Integration of tan x dx. We'll use substitution. So I can write tan x as sin x upon cos x. Now, if I take cos x, f of x, so this will be minus f dash of x. I hope you are getting it because cos x, the derivative is minus sin x, right? So that means I need to put f of x equal to t. So let cos x equal to t. Then I'll differentiate with respect to x. So I'll get minus sin x dt over dx. So if I cross multiply, I will get sin x dx will be equal to minus dt. So if I substitute these both in my question, what will I get? I will get integration of minus dt into 1 upon t. Now minus is a constant. So according to rule number 1, I can write minus integration of 1 upon t dt. And what is the integration of 1 upon t? It is very simple. It is log t, but with a minus because we had minus plus c. Now, if you know the property of log, this minus will come on the exponent. That means I can write it as log of t raised to minus 1. And what is t raised to minus 1? It is log of 1 upon t. And if I resubstitute, I will get log of 1 upon cos x plus c. And what is log of 1 upon cos x? 1 upon cos x is sec x plus c. This is my answer. I hope you are getting it. Very simple. Got it? Okay. Now let's move on to more questions. Yeah, these are some important questions based on trigonometry. Trigonometry means we need to know what we need to know: the compound angle, allied angle, multiple angle, factorization, and defactorization. Now, this question here is not integrable form. It is not of integrable form. So what do we do here? We convert into integrable form by using trigonometry. Sorry. So let's say, suppose I take this sideways. So consider sine 6x into cos 3x. Now what did I did here? I multiplied and divided by 2. So what I got it as 2 sine sine. What is 2 sine cos? It is sine 6x plus 3x plus sine 6x minus 3x upon 2. So that is 1 by 2. I'll take it out. I will get sine 9x plus sine 3x. Okay, so that means my question will look like integration of 1 by 2 sine 9x plus sine 3x dx. I hope it you understanding. Now this is an integrable form. We'll use both the rules, the addition rule and the constant rule. So 1 by 2, I will get integration of sine 9x dx plus integration of sine 3x dx. And it is very simple. 1 by 2, integration of sine is minus cos. Now don't forget, here we have linear term. Means we have to divide by 9 minus cos 3x upon 3 plus c. So if I take LCM and minus common, I will get minus 1 by 18 cos 9x plus 3 cos 3x plus c. Got it? This is my answer. So here we don't need substitution. Mainly we use trigonometry formulas to get it solved. Got it? Right? Next. Let's look at next question. Oh, this is a very important, good question. So if you remember, we will again consider here. I can write tan 3x as tan 2x plus x, right? And here I can use tan a plus b formula. What is tan a plus b? It is tan a plus tan b upon 1 minus tan a into tan b. And left hand side we have tan 3x. If I cross multiply here, if I cross multiply it here, so I will get, can you see it directly? I will get tan 3x minus 1 into tan 3x, tan 3x minus this into tan 3x, that is tan 3x into tan 2x into tan x. And on the right hand side, I will get equals to tan 2x plus tan x. If I rearrange this, like if I bring this all this term on the right hand side, so I will get, it will become positive tan 3x into tan 2x into tan x. And I will bring this on left hand side, which is equal to tan 3x minus tan 2x minus tan x. That now means, what have I done? By using trigonometry, I have converted this into integrable form. It's tan 3x into tan 2x into tan x. I can now write it as tan 3x minus tan 2x minus tan x dx. Right? And by using the addition subtraction rule, I can easily write it as integration of tan 3x dx minus integration of tan 2x dx minus integration of tan x dx. So what is integration of tan? We just derived this here, tan log mod sec. Got it? So here log mod sec 3x, but don't forget upon 3 because it is linear. So you have to divide by coefficient of x minus log mod sec 2x upon 2 minus log sec x. No need to upon 1, right? Plus c. This is my answer. Very simple. I hope you got it. Let's move on to next question. These are very important questions because these involves trigonometry. And whatever involves trigonometry, automatically they become important. Right? So let's look at this. Now, this is a very simple question. You just need to remember the multiple and submultiple formula. So 1 plus cos is 1 minus cos is 2 sine square x, if you remember. And 1 plus cos is 2 cos square x. Here 2 and 2 will get cancelled. Sine square upon cos square will be tan square. Now, do you know the integration of tan square directly? No. So we will use identity. We will use identity. That is, I can write tan square x as sec square x minus 1. Sec square x minus 1. So by the rule of second rule, the subtraction rule, I can write it as integration of sec square x dx minus integration of 1 dx. So what is integration of sec square x dx? Tan x minus integration of 1 is x plus, see, this is my answer. I hope it is very clear to you all. What is my answer here? Got it? Okay, let's move for the next question. Here, this is again a very good question. If you know, 1 plus sine 2x can be written as cos x plus sine x, the whole square. Just see, this is a formula from trigonometry. Do you remember this? I hope you remember it. So that means I can write 1 plus sine 2x as cos x plus sine x the whole square. Right? So, what modification can I use? Can you simplify it? Or are you able to see it? How, what modification should I use? Or can I use? Trigonometric modification. Or should I do it? Okay, let's do it. I guess there's a mistake in question. It should be here plus. Yeah. So I will be getting integration of cos plus sine upon cos plus sine the whole square dx. So one of them will get cancelled and I will get 1 upon cos plus sine. This is still not an integrable format. So what we can do here? I guess there is something mistake in the. Let me check what is the mistake. Why the question from somewhere else? Printing mistake, I think it is. Let me check once. Yeah, got it, got it. No, no, it's no, the mistake is this will be minus, right? So if I put cos, okay, so my integral will be integration of cos x minus sin x upon cos x plus sin x, the whole square dx. So if I put cos x plus sin x is equals to t, that means this is my f of x and this is my f dash of x. Got it? So if I differentiate with respect to x, so cos x का derivative is minus sin x plus sin x का derivative is cos x will be equal to dt over dx. So that means if I cross multiply, I will get cos x minus sin x dx is equals to dt. So with these substitution, this one and this one, my question will become integration of, here I'll get dt, here I'll get 1 upon cos x plus sin x. What is cos x plus sin x? Is t. This will be t square. And to do this integration of t square, we use t raised to minus 2. What is integration of x raised to n? This will be t raised to minus 2 plus 1 upon minus 2 plus 1 plus c. So that means I will get minus 1 upon t plus c. I hope what is 1 upon t. That means I will get minus 1 upon, in place of t I can write cos x plus sin x plus c. This is my answer. I hope you got it. Right? Minus 1 upon cos x plus sin x plus c. This is my answer. Now, before starting next topic, we better not start because we have very few minutes left. Let's go through the questions again, or we what we did. So first, we did what is meant by integration, right? It is a reverse process of differentiation. So that is basically, it is also known as antiderivative. Then we saw the symbol of integration. Then we saw the standard formula. This standard formula comes from derivatives. So this formula comes from derivative. So if I just read the formula of derivative ulta, that is from right to left, I will get the formula of integration. Then we did some rules or properties, you can say, which was the constant rule and the addition and subtraction rule. After that, we looked at some questions like this one. Yeah. Same logic applies. If square root, then my mind should automatically think we should rationalize. Then next was the questions again. Then substitution, very important. Very important. To make a non-integrable function integrable, we basically use substitution. It is very important to use substitution to make non-integrable function. If we see any composite function, 100% we need to use substitution. Don't forget that. Got it? So here we saw composite function, we put it as substitution. This was a very interesting question. The next one, because we know composite function. So that means we have to think how to use substitution. The next was this. Lastly, the standard integrals or the 4 other standard integrals which we had left starting May. We saw the proof of one. Accordingly, you can do the other proofs. This one now by using trigonometry. It is very important. And this was a very good question again. And lastly, this and this question we got stuck. Thank you all for helping me. I got the question is wrong, but no, it was fine. So that's all from my side. You can leave now. All the best. This week you have AIET test, right? So all the best for that. I hope you all do very fine. The papers are good. Like all the best. Okay, we'll meet soon. Bye bye. Take care.